Now let's look at a third example. Find the critical numbers for f of x equals 4 over x plus x over 4. I want to begin by noting something. Remember that a critical number can only occur where the function is defined. This function is not defined at x equals 0. So x equals 0 cannot be a critical number. The function has to be defined at a critical number. Alright, so, well, let's rewrite this function. F of x equals 4 x to the minus 1 plus 1/4 times x to the first. Alright, so the derivative is going to be negative 4 x to the minus 2 plus 1/4 times 1, and that's negative 4 over x squared plus 1/4. Is the derivative ever undefined? It is undefined at x equals 0, but remember, x equals 0 cannot be a critical number, so we pass on by that. What we need to do is now look for places where this might be 0. Alright, so let's set this equal to 0. And I'm going to rewrite this equation by pulling the negative 4 over x squared over to the other side, so we get 1/4 equals 4 over x squared. Now the reason I did that is that I want to use the principle of cross multiplying. If two functions are equal, then the products you get by multiplying in this direction and multiplying in that direction must be equal. So that means that x squared must be equal to 16, which tells us that x must be either plus or minus 4. We check to make sure that the function's not undefined at 4 or negative 4. It's not. So those are both critical numbers. Now let's look at how to find absolute extrema on a closed interval from a to b. Alright, so we're going to assume that our function is also continuous on the interval from a to b, so that we're guaranteed that there are actually maxima and minima. And you will remember our discussion from earlier. On a closed interval, the maxima and minima must occur at either one of the endpoints or at one of the critical numbers. So this technique is not very complicated, or it's not a complicated idea. What we do is find all the critical numbers that are inside the interval, or that lie on the interval, and then just evaluate the function at all the places where you could have a maximum or minimum. That is, you evaluate the function at both endpoints, and you evaluate it at all the critical numbers that lie on the interval, and the biggest y-coordinate, that's where the maximum is, and the smallest y-coordinate, that's where the minimum is. So let's take a look at this example. Find the extreme values of f of x equals 1 plus 3x minus x cubed on the closed interval from negative 4 to 0. So what we need to do first is find the derivative and then look for critical numbers that lie on the interval from negative 4 to 0. So f prime of x is 3 minus 3x squared. That's never undefined, so we set it equal to 0. And we get x equals plus or minus 1. However, the positive 1 is not on the interval, so the only critical number of any interest to us is the negative 1. So, what we need to do now is evaluate the function at each of the endpoints. So we evaluate the original function, this one, at -4, because that's the function whose maximum and minimum we're trying to find. F of 0 and f of -1. F of -4 is going to be 1 minus 12 minus -4 cubed is -64, I believe. Substitute in 0, and that's 1. Well, that was easy. And f of -1 is 1 plus 3 times -1 minus -1 cubed is -1. So let's see, this is going to be 64 minus 12 is 52, plus 1 is 53. And this is 1 minus 3 plus 1. I believe that is -1. So the absolute maximum occurs at x equals -4, y equals 53, and the absolute minimum occurs at -1, -1.